So previously, we did cover for chapter 3 and 4. So we have done variables and we have done input output. So for today's lecture, we will continue on arithmetic operations and also the math functions. Okay. So let's start the lecture session. So a little recap on variables in terms of keywords, how to declare some examples, things like that. Okay, you can view the previous video to refresh on the variables. So for today, we will continue on operators. Looking into the C operators, so there are a few things in terms of increment, decrement, relational operators, logical operators, things like that. And no worries, I'll show some example in code blocks in a while. So things when we talk about operators is the addition or the plus symbol, subtract or the negative symbol, multiplication or you times with the asterisk symbol, and then division with the slash, and also modulus or remainder. Okay, so I'll show the execution of these operators. And once we have looked into that, we'll be seeing into the increment and decrement. This operator, you will be using this frequent in your chapter 5, where you will do looping and things like that. So I'll also show some example on that. And then finally, we will look into the relational operator. These are the operators that you can use when you want to perform selection or conditional statements. Those are things that we will learn in chapter 5 as well. So no worries on that. But for today, we will take a look in terms of the execution of those operators. All right. And same goes to this, the logical operators. So let's take a look. So as usual, we'll start with the create new project, console application, C, and the title is lecture week 4. Okay. All right. So coming back to the topic 3. So first we're going to take a look on the C operators. So we will take a look on the addition, subtraction, multiplication, and so on. So how do we perform in C programming? Of course, we start with, we have to declare the variables that we want to use. So let's take a look in the data type integer. So let's name our variable integer A and integer B. All right. Okay, so once we have done that, and of course, we're going to do addition, subtraction, and so on. So we want to save the output or the values of the calculations into another variable. So we'll need 3. So we have integer A, integer B, and integer C. So it's declared as integer type, but it doesn't have any values yet. So once you have done the variable declaration, let's assign some values. So let's assign A to the value 2 and B to value, say, 5. Okay. So before we perform like addition, subtraction, and so on, let's create this one statement of printf in order for us to view the output or the calculation. So the value of C. So it's going to be an integer, and we're going to output the variable C. All right, just some new line. Just some formatting. Okay, so first thing we're going to do is that let's do an addition. So in C programming, what you have to do is type in the variable that the end product that you want. Okay, put it equal, and then perform the calculation. So in our case, we want to try A, we add or plus with B. So a simple addition. So once we do this, and if we build and run, we're able to see the output of the calculation. So in our case, A plus B is equals to 7. So of course, the example is a simple one. In your case, when you're playing with equations and things like that, it will be slightly more complex. But right now, let's take a look on the basic. So that's for addition. And say if we do minus or subtract, we'll run this again. And you will see the value C equals to -3 because 2 minus 5. Okay. So same goes for multiplication, which is the asterisk symbol. And when you run, you'll see the value. So A times B, you get 10. So it goes same for division. In this case, it's 0 because A is a smaller value. So it's 0. If we change or turn it the other side, 5 divided by 2, supposed to get 2. Okay. But then you might have a question, okay, so in this case, why is it 2? Isn't it supposed to be 2.5? Okay, for that, I'll show. In order to get that, there are methods to do for that. So before that, when we talk about division, if you take a closer look in the slides, there's one part where we have this modulo division or remainder after division. So when we look at this example, when 5 divided by 2, it's supposed to be 2.5, but since there's 2, if you look at standard division method, there is a remainder, which is 1. So how do we obtain that? So all you have to do is switch this to the percentage or modulo, and you'll get the remainder. So 5 divided by 2 is 2, and there's a remainder 1. Okay, so those are the execution of these basic operators. But coming back to the example earlier that I said that it's supposed to be 2.5, right? So for that case, in order for you to get the 2.5, you need to change the data type. So in our case, we need float. It can be double, but let's keep it float. And you put the division, and you have to change this to formatting output, which is F for float. And when you run this, there you go. You'll get the exact. So if you want the exact in terms of decimal places and things like that, you have to use float. If you use integer, you will not get the remainder. All right. So formatting for this, I've explained on the previous lecture. Just add the front of the type here, which is if you want 2 decimal places, then it's 0.2. So you'll get in a proper formatted. Okay. So those are the basic in terms of arithmetic operators. Next, we will look into the increment and decrement. So it's the same. What you have to do is just add the plus plus or minus minus. Okay. So let's do that. So for increment, in our case, let's have increment for the variable a. Let me remove the variable b. So if you do a plus plus, what happens that you'll increase this value to 1. So let's take a look. In our case, back to integer. And this will be d. And the variable that we would like to take a look is a. So in order to see the difference, let's print out before the increment and after the increment. So this is for before, and this is the value of a after performing the increment. Okay. So when you run, before it's 2, a is equals to 2, and when you use the increment or a plus plus, it will increase the value to 1. So if this is 10, then it will increase to 11, and so on. So the before is 2, and after increment is 3. Okay, same goes to decrement, which is minus minus. Before is 2, and after the decrement, it's 1. Okay, but here's a trick. When we take a look at this, increment and decrement, there are two possibilities of using these increment or decrement operators, which is you can put it as a minus minus, or you can put it in front, minus minus a. So what's the difference? Okay, for this, if you put before or prior to the variable, you will increase the value or decrease the value first. Then only you will display the variable's value. Okay, but if you put it after, say in our case, say it's a plus plus, when you put it after, what happens is in this line, line 12, if you do any printing, the value of a will still be 2. And after line 12, then only it will do the increment. But of course, if I execute in this style, you'll not be able to see it. Let me just show you guys. If you notice, the plus plus a before and after, it's still the same here. Okay. For you to view that, what did I explain earlier, is by actually performing it here. Okay, so we'll remove this. And we will output and take a look. Okay, so a equals to 2. So supposingly in this line, your a is still 2. Only at line 12, your a is supposed to become 3. Okay. So when the increment is after the variable, so you will only add or perform the addition or the increment right after this line. So as you can see, even though we put the a plus plus here, it still output the value 2. But then right after that, it's increased another one. So it becomes 3. Okay. But if we put it earlier, you will perform the increment first. Then only you will display the value. So if you notice, earlier it was 2, but now because we put plus plus a, it will increase first and then only it will display the value. So the increment happens prior to this line. All right. So this one, it has effect when you are performing like certain loopings and things like that. If you would like to do the increment or the decrement before the value is being changed, then you have to put it on the left, and then if you want the increment or decrement to happen on post, which is after, then you put it on the right of the variable. So it's the same for the decrement. Okay. So as you can see, it minus first. So a equals to 2. When it comes to this line, it minus first, then only display. Therefore, it shows 1. And then after that, the value of A is still 1. Okay. But if you put the decrement minus after, then the initial value is not changed yet in line 10. So A is still 2, but then it performs the decrement right after that. Then A becomes 1. Okay. So that's on the increment and decrement. Okay, looking at relational operators. Okay, these are operators that you will be utilizing on chapter 5 when you perform conditional statements, looping, things like that. But let me just give a quick run through on how do we use these operators. So what we're going to do is we're going to go back to the example earlier. So we have A equals to 2 and B equals to 5. So I'm going to remove this first. So what I want to test is basically the equal sign. The double equal sign is meant to validate or verify that the variable on the left and the variable on the right, are they equal or not? And this is for greater than, less than, this is not equal to. So let's take a look. To test that, we have to use the condition statement. Don't worry about this because we will learn this in chapter 5. So we're going to test if A is larger than B. So this operator we use to test that the left is larger than the right. And if this statement is true, then only the codes are executed in this line. If it's not true, it will skip this entire line 11 to line 14 and it will proceed straight to line 16. Okay, so to test that, let's make an output so that we can actually validate and verify it by just stating the true. So if it's true, if this condition is true, then we know it's true and we will be able to display this line. Okay. And we don't need this. So we're just going to put as outside of the if condition. Okay. So let's test this. We do know that A is actually smaller. So if you look at our output, it's outside of the if condition. So it did not execute the statements inside here. Why? Because this is false. So same goes to other operators. Okay. Say if we test the true, which is A is actually smaller than B, we'll be able to execute the line inside that only if and only if it's true. So same goes to other conditions. If you want to check whether these two variables are equal, so you just have to put the double equal sign, and we know it's not true, but let's make it true. So in order for it to be true, it has to be same. So if A is 5 and B is 5, then this will be true. So we'll be able to execute that line inside. Okay. So same goes to the others. The other operators, yes, you can play around with it. So those are the examples on that. Okay, here's another one. Logical operators. Okay, this will be interesting when you want to test two different types of condition or two different type of statement at a single condition statement. Okay, you can use the and or the not. Okay, so let's take a look. If I want to check whether A is equal to B, and at the same time I want to check that is A larger than B. Okay. For N, both has to be true. If either one is false, it will not execute this. In our case, we do know. Mathematically, this is not true. A is not larger than B. So this statement will not be executed. So let's test. As you can see, it did not execute inside because this statement is false. Because N requires that both the left and the right to be true. But if you want to test either one, then we will use OR. And as you can see, it's true because A is equal to B, but then it's not larger. But if we make this 6, it should also be true because it's OR, either one. So there you go. These are things that you'll be using when you're performing your equation computations, or if you're playing with logic boards, the circuits, thing like that. Yes, you'll be utilizing these logical operators. Okay. So those are the operators. And now we will proceed with the math functions. For this, I believe you guys will be using this a lot in terms of logarithm, exponential, power, square root, things like that. Okay, for this, what you have to do is basically you need to include an additional libraries. At the moment, we have the standard input output and we have the standard library. So we have to include another library, which is include math.h. And once you have done this, you'll be able to use all the functions which is stated here. And if you're curious and you would like to explore even more, you can actually Google for it. Math for C. There's a lot of websites available, but take a look at tutorials point. And yes, for this library math. And these are the functions that you can use. So if you have sine, cosine, tangent, double, square root. And do keep in mind that the execution for these functions, the variable is supposed to be declared as double. So let's take a look for square root. Okay, we have square root here. So if you click on here, you'll be able to see the condition or the syntax that is required, which is it has to be a data type double. And the function sqrt is for square root. And you have to put the variable that you want to perform the square root. And it has to also be in the data type double. And they've included some example. But no worries, we'll take a look in a while in our code blocks. So once you have done this, we have A and B. So let's try. C equals to square root. We're going to use the square root function. And we're going to use the variable A. So square root of 6. But remember, I told you guys just now that this requires the data type double. So you need to convert this to double. And let's output the value of square root. C is for double or float, we will use the F, but for double is LF or long float. Okay. Don't forget that. If you're using just float, then it's just F here. Okay. So the variable C. So this is the value, square root of 6. is 2.449490. And if you like to format this into like 4 decimal places or 2 decimal places, all you have to do is same as before. Just add the point and how many number of decimal places do you want. If it's 2, then 0.2. And then it will be formatted accordingly. Okay, so same goes to the other functions for power and so on. But for power, you have to remember that it requires, let's take a look. Where is power? Okay, for power, it requires two variables. This would be the base and this would be the power of. Okay, so let's look at the example. Let's say we want to do that. A power of 5. So we're calling the function power, which is POW. Your base is A, so we want 6 power of 5. So A will be there, and the power will be here. So 6 power of 5 is 7,776. If you look at a simpler version, say 2 power of 3. And you get 8. Okay, so for the math functions, mostly for this library, you'll be handling with the double or float. Integer, no, it doesn't run. Okay, so feel free to explore. So that's, yep, those are the math functions. That's a lot. And yep, that's all for the lecture for today, which is up to math functions. On next week, we will proceed to topic 5, where we will take a look into control structure and looping. The example that I showed earlier with the if-else statement, things like that, those are on chapter 5. So yep, that's all for the lecture today.